जय हिंद स्टूडेंट्स, मैं हूं डॉक्टर प्रीति मित्तल, आपकी साइंस टीचर। लास्ट वीडियो में हमने एक्सेलरेशन टॉपिक डिस्कस किया था एंड आज देखते हैं हमें कितना अच्छे से समझ में आया ये टॉपिक बाय प्रैक्टिसिंग सम न्यूमेरिकल्स। वी आर गोइंग टू लुक एट द क्वेश्चंस गिवन इन द एनसीईआरटी बुक आफ्टर द टॉपिक एक्सेलरेशन। So let's start with our first question. First question says that how will you say that an object has uniform acceleration? So this question is having two parts. We are discussing the first part first. So how will you say that the object is there in uniform acceleration? When an object is moving in a straight line and its velocity is either increasing or decreasing uniformly. Uniformly means it is increasing or decreasing at equal amounts in equal intervals of time. Then such a motion is known as uniform acceleration. And example of uniform acceleration is whenever an object is coming towards the ground under the effect of gravity. Suppose you take a stone in your hand and you just drop it, you just leave it, then it will be coming towards the ground under the gravitational pull of the earth, and it will be ever increasing its velocity. It will start with zero velocity because you have just dropped that stone from your hand, and continuously it is when it's coming towards the earth, its velocity is going to increase by equal amounts in equal intervals of time. So whenever an object is in free fall, such a motion when object is coming towards the ground only under the effect of gravity, that is known as free fall. और ये free fall है, that is an example of uniform acceleration. तो जब भी कोई object free fall में है, it's coming towards the earth by the action of gravity pull, then it is known as free fall. And that type of motion is an example of uniform acceleration. Second part of the question says non-uniform acceleration. So whenever in day-to-day life we are moving from one place to another, then either we are not moving in a straight line or our velocity is sometimes increasing, sometimes it's decreasing, then it is an example of non-uniform acceleration. That type of motion is known as non-uniform acceleration. So how we'll define non-uniform acceleration? If an object is either changing its direction or the object is having increase or decrease in the velocity that is not in equal amounts in equal intervals of time, then it is known as non-uniform acceleration. Okay, example of non-uniform acceleration is movement of a car on a busy road. So when a car is moving on a busy road, that follows non-uniform acceleration. कभी कार की speed तेज होगी, कभी धीरे हो जाएगी, and so it will be having non-uniform acceleration. Okay, now moving on to second question, which is a numerical. Let's see. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. What is the acceleration of the bus? So in this question, it's given that a bus was there and it was initially moving with a speed of 80 km per hour. Now, this will be represented by U because this is the initial velocity. Initially वो किस speed पे move कर रही है? 80 km per hour. फिर वो ब्रेक अप्लाई करेगी और फाइनली उसकी वेलोसिटी हो जाएगी कम एंड इट विल बी 60 किलोमीटर पर आवर. टाइम कितना लगेगा इतने इस चेंज में? दैट इज 5 सेकेंड्स. नाउ अगर टाइम भी आवर्स में होता तो हम एक्सेलरेशन किलोमीटर पर आवर सेकेंड स्क्वायर में फाइंड आउट कर सकते हैं, बट सिंस टाइम इज गिवन इन सेकेंड्स वी हैव टू डू द कन्वर्जन और हमको वेलोसिटी को भी कन्वर्ट करना पड़ेगा मीटर पर सेकेंड में. सो लेट्स डू द कन्वर्जन. First, the initial velocity. Initial velocity is 80 km per hour. So, 80 into 1 kilometer is 1000 meters. हमें मीटर पर सेकेंड में कन्वर्ट करना है, तो हम किलोमीटर को मीटर में कन्वर्ट कर देते हैं. Now, 1 hour is 3600 seconds. So, just divide it by 3600. जब हम इसको डिवाइड करते हैं, तो it comes out to be 5 by 18. 1000 upon 3600 आप अगर डिवाइड करोगे, तो that comes out to be 5 upon 18. याद रख लो, हमेशा काम आएगा. Then we have to divide it further, so it will be 2 9 times 2 40 times is 80, and just multiply that, we get 200 divided by 9. Okay, now final velocity is 60 km per hour. Do it by yourself and convert it into meter per second. I'll doing for myself, you do it for yourself. 3600. Now it's 5 upon 18, 2 9 times, 2 3 times is 60. That is it. Okay, now you will say, ma'am, could be divided further because 30 upon 9 could be still divided. But we won't divide that. We'll let it be like that only. क्यों हम divide नहीं करेंगे इसको? क्योंकि denominator में 9 है and इधर भी denominator में 9 है in case of initial velocity also. Denominator same होगा तो हमें LCM find करना easy हो जाएगा because we have to just find the change in velocity. तो इसलिए हम denominator दोनों का same रहने देते हैं and it comes out to be 30 times 5 is 150 and divided by 9. Okay, टाइम तो 5 सेकेंड्स है ही सही. अब आपको पता है एक्सेलरेशन का फॉर्मूला होता है चेंज इन वेलोसिटी पर यूनिट टाइम मींस v माइनस u अपॉन t. पहले चेंज इन वेलोसिटी फाइंड आउट कर लेते हैं. लेट्स फाइंड आउट द वैल्यू ऑफ v माइनस u. सो लेट्स फाइंड आउट v माइनस u. आप डायरेक्टली इसी स्टेप में भी कर सकते हैं या सेपरेटली भी शो कर सकते हैं. ओके, सो लेट्स फाइंड चेंज इन वेलोसिटी is equal to v minus u. Let's find out what's v. V is 150 upon 9 minus initial velocity was 200 upon 9 and that will be equal to minus 50 upon 9. Let it be like that. Okay, now using this value in the formula. Okay, so a is equal to v minus u upon t. v minus u की value आई है minus 50 upon 9 and time is 5 seconds. So it comes out to be minus 50 upon 45. Okay, if we just divide that, we'll get minus 1.11. You can just divide it first by 5 also. Huh? 5 10 times is 50, 5 9 times is 45. 10 upon 9 will give you minus 1.11 meter per second square. Since it's acceleration, remember that it should be in meter per second square. Okay, so that's a simple solution of this. Why the answer is coming negative? नेगेटिव आंसर शो करता है कि वेलोसिटी डिक्रीज हो रही है, जिसे हम कहते हैं रिटार्डेशन या डीएक्सेलरेशन. ओके, तो इधर डीएक्सेलरेशन हो रहा है, रिटार्डेशन हो रहा है एंड दैट इज शोन बाय नेगेटिव साइन. ठीक है, सो आई विल जस्ट शिफ्ट टू साइड. सो इफ यू वांट टू टेक अ स्क्रीनशॉट यू कैन टेक दैट. नाउ क्वेश्चन नंबर 3 फ्रॉम दिस टॉपिक. A train starting from a railway station. Starting from a railway station means initial velocity will be 0 and moving with a uniform acceleration attains a speed of 40 km per hour in 10 minutes. Find its acceleration. So let's have a look at the solution. It's given that initial velocity is 0 because the train is starting from rest. So whenever anything is starting from rest means initial velocity उसकी 0 है. Final velocity is given 40 km per hour. अब इसको कन्वर्ट करते हैं मीटर पर सेकेंड में. एक्सेलरेशन के सारे क्वेश्चंस में ही आपको मीटर पर सेकेंड में कन्वर्ट करना है, ये ध्यान रख लो बच्चों. एवरी टाइम विल बी डूइंग दैट. ओके, so 40 km per hour is equals to 40 into 1 kilometer is 1000 meters upon 3600 seconds. That will come out to be 5 upon 18. 2 times 20, 2 times 9. So it will give us 100 upon 9 meter per second. So final velocity is 100 upon 9 meter per second. Time is given 10 minutes. इसे भी हमें ऐसा यूनिट में कन्वर्ट करना पड़ेगा, that is seconds. So 10 into 60, that will give you 600 seconds. Okay, now we have to just find out the acceleration. तो वही simple formula जो हमें याद हो चुका है. Final velocity minus initial velocity upon time. Final velocity है 100 upon 9 minus 0. Minus अगर आप किसी भी नंबर में से कोई भी 0 करते हो तो you get the same number only. So we need not subtract 0 from this. Now divided by time and that will be equal to divided by 600. Zeros gets cancelled out. So it comes 1 upon 54 meter per second square. It's positive because initial velocity is 0 thi and final velocity is increasing to 40 km per hour. Okay, so that's the solution of this question. It was an easy one, I think. Okay, I'll just shift aside so that you can take a screenshot. So related to this topic, we have just 3 questions in our book that we have completed and we will be practicing many more questions later on. Okay, so that's all for today. That's all for this video. I hope you were able to understand the concept of acceleration. It's very, very important for your exams. Definitely in your exam, you will be having a question based on this concept. So just practice it very well. We'll be practicing many more numericals also based on the same concept. But for this video, that's all. Take care of yourself and have a very nice day.